Hello ladies and gentlemen, welcome back to C.A.R. Entertainment. I'm your host Alan Hamilton, guys, and today we're going to be moving on for A21 Digital Technology Revision videos. Last time we talked about networks, and I said later on we talk about a branch of it called network topologies, and that is exactly what we're going to be doing today, guys. We're going to talk about network topologies. Could be a shorter video than the rest, but we'll see how it goes. I might blabber on like I usually do, but it's all about giving you the extensive knowledge and everything you need to know in order to pass your exam. So we're going to get straight into this, and hopefully I can bring you that. So we firstly start off with the first two branches. So you come off networks and do the topology section, and then you have physical and logical topologies. A physical topology is how the cables and devices are laid out and connected on the network. So this is just the actual layout. It's like a blueprint. You have every computer, every node, and then you have all these cables and devices, and you see them how they're laid out and how they're connected on the network on the blueprint. That's essentially a physical topology. Then you have a logical topology, and this is the way the network will behave or work, and this is determined by the network interface card. So you'll have, I wouldn't really say it's more of a blueprint, more like code sort of thing. You have your network interface card and how that is making the network behave or work. And this means that the network can perform properly and all devices can form the same logical topology. And so it's essentially meaning all the nodes on the network are forming the same logical topology. They're all working and behaving in the same way because they're all using a similar network interface card. So let's get through and talk about the actual different topologies then. So with a little bit of ring topology, I think the only ones we're going to go through are physical topologies, but there's different phases of logical in them. But the first one is a ring topology, and this is where nodes are connected together without a file server. So essentially, if you just picture a circle and then just put a pile of computers around that circle, and the data flows in one direction only, so either clockwise or anti-clockwise. And so the token, or your information, will be passed from node to node or from computer to computer, and whenever the node has the possession, they will have sent the message to the network, and it will be passed along each node until it eventually arrives at its final destination, the node it was intended for. So data will travel in one direction only, meaning it will avoid collisions. So nodes are connected in a loop. To add a new node in a ring topology, then existing cables will have to be severed and broken. This means that the broken connection will cause the network to fail, and it's possible to isolate a faulty node. So essentially, it's not great if you have to add a new node because you're stopping the whole thing and nothing else can happen. Data will travel large distances, which can lead to problems in data signal as it tends to weaken whenever you have to travel long distances. The advantages of a ring topology is that transmission will be simple as it only travels in one direction. There will be no data collisions, and you can add a node with little effect on performance other than the fact that, and a disadvantage of it, if a single node is off, the network won't work. Even if just one of them is turned off, the network won't work. If a cable breaks, the network won't work, and it's difficult to identify problems as well. A bus topology is our next one, and this is whenever nodes are connected onto a main cable where data is transmitted in both directions with terminators at both ends. Just picture a straight horizontal line, and then you have branches coming down and up, and where there'll be a node on the end, and then essentially this main horizontal line, that's where data flows left and right with terminators at each end. So every node will transfer data directly to another, and this is sent onto the main cable. So if I have a node at the bottom left, it will send it on the main cable, it will pass all the way to the right and up to the top right node. So that's how it transfers data. If one node isn't working, then the network can still operate. It's easier to add a new node than a ring topology, but the more nodes added on, then the slower the transmission speed will be due to increased traffic on the main cable. If there's more than one node sending a message at the same time, this will lead to a data collision, but you can avoid collisions using CSMA or CD protocol. This involves each node checking if the main cable is busy before sending the message, and if it's busy, then the terminal will wait. But if a collision occurs, then the node will retransmit the same message at a later time. This is how it gets around that problem. So the advantage is that it's easy to install and it's easy to add extra workstations, and it uses less cable than a star network, which is our next one we'll talk about. The disadvantages is that if there's a problem with the central cable, then the entire network will stop working, and if there's a lot of workstations on the network, then data will travel slowly, and finally there's low security as every workstation will see all the data in the network. So the star topology then, what is it? Well, a star topology uses a central file server with each node connected to it by its own cable, and the host will control communication. So it's all basically connected. You have this file server in the middle, and then you have all these different nodes connecting to it. And if a file server will fail, then the whole network's going to fail. Each node will have their own connection to the hub, or the file server, and there'll be no connection for these pathways. So if the node fails, then the network will still operate. You can add a new node by just simply connecting it to the hub if there's capacity to do so, and it's more secure as a server will send data directly to the intended recipient and nobody else can see it. It's reliable as if one link fails and only one node's affected, all the other ones will still operate. The advantages is that it's reliable, as one connection fails it doesn't affect the others. There's few data collisions as each node has its own cable to the server, and there's good security as no node will interact without going through the server. Disadvantage is that it's the most expensive one here, as there's a lot of cables. The installation of one needs a lot of experts. Hubs and switches are needed, and if the server crashes, then nobody has access to any of their files. Thanks for watching this video. I've been Don Hamilton from C.A.R. Entertainment, and I will see you next time.